notes you're writing down that a rational exponent is an exponent that is a fraction. Forgot to turn this on earlier. Okay, so we learned that y equals 2 times 3 to the x is the equation that produces this. What number is this on your assignment, you guys, again? Number 12. Okay, that produces this thing right here. But we also learned we can get it by multiplying by the square root of 3 each time. Or we can use the rational exponents. Like the next one's going to be 5/2. So let's do the next one to the 5/2 power. So we have y equals 2 times 3 to the 5/2 power. Okay, 2 times 3 to the 5/2 power. So we have 2 times, what's the radical? Okay, so what goes in the index right here? 2, but we don't usually write it if it's 2, right? 3 to the what? 5th power, that's right. Yeah, that's 243. However, we could do this. We know that 3 to the 5th power, it breaks down to 5 3s, right? We have a pair of 3s, another pair of 3s, and what I call a loner 3. Okay? And so what happens when we simplify this, we have this 2 that we bring down, and 3 times 3 is 9, and the square root of 9 is 3, so we bring out one of those pairs. Once again, 3 times 3 is 9, the square root of 9 is 3, so we bring out that pair. But the loner goes back inside, right? So I get 2 times 3, which is 18, times the square root of 3, so 18 root 3. We could have just gotten that by knowing that we times 18 by root 3, right? So then we have, if I times root 3 by root 3, I get 3, and 3 times 18 is 54, so that gives us the next one. What's the next term? 54 root 3. So put that one on your paper, because I think that's there, right? 54 root 3. And what's your next one? 54 times 3, which is 162. Okay? Do we get that? So, you guys, do you see when all of a sudden we have a geometric sequence, and we're not just taking the integers, like 0, 1, 2, 3, 4, and so forth, and all of a sudden we're going up in halves, do you see how now the number we multiply by in our geometric sequence becomes the square root of 3 instead of 3, right? It became the square root of 3 instead of 3. Do you see the need for rational exponents now? Okay, there's an well, if we didn't have rational exponents, could we get these numbers in between? We wouldn't be able to get these numbers in between, right? We wouldn't have a way of expressing them anyway. So that's why we have rational exponents. What is a rational exponent? I want everybody to tell your face partner what a rational exponent is again. Okay, now, I want you guys, I'm going to give you a minute. I'm going to give you about 2 minutes in your group to do number 13. Go. Hey, I heard some, okay, all eyes right here now. I heard some really good stuff when I walked around. Some of you guys are getting this. Good job. Who would like to come in and fill in our next one? Okay? Okay. Okay, one thing we know, you guys, do we know it's going to be the same equation? Yeah, how do we know that? Yeah, because this was 2, this was 6, and it said it's still triplets for whole numbers, right? So it's the exact same pattern as before as far as the whole numbers go. This time we're taking thirds of it. Who would like to come in and fill in what they got? Christian, go ahead. Yeah, you can. Okay, so Christian's going to fill this in right here. Yeah. Okay, good. So what is the number you're timesing by every time, you guys? By 3? Well, 3 for the whole numbers, but if we went to the third and then 2/3 and then that, which number are we timesing by every time? We're cube root of 3. We're timesing by this number every time, you guys, the cube root of 3. Now, I want you guys to go back to, let's go to the very first one, the 1/3 one right here. If we were to use this formula, because it's the same formula, isn't it, that we used on the previous one? Y equals, I need eyes up here because some of you guys don't understand and you're not watching here. It's the same formula. So y equals 2 times 3 to the 1/3 power. So how do you change 3 to the 1/3 power to a radical? Where does the bottom 3 go right here? Yeah, it goes as the index right here. It's a cube root, right? Whatever number is on the bottom is the root that we're taking. It's the cube root. 3 is the radicand, what we call the radicand, the number that goes inside, to the 1 power, right? So this first one, we took 2 and we times it by the cube root of 3. That's what we got. Now, if you times the cube root of 3 times the cube root of 3, well, 3 times 3 is 9, so you get the cube root of 9, right? Okay? The other way you could have written this as 2 cube root of 3 squared. Because you're timesing it cube root of 3 times the cube root of 3. But you can write it short by writing cube root of 3. The cube root of 9. Now, how does that relate to this? Well, look, you guys, if I would have had the 2/3 power right here, see this 2/3 power? The 2 was this power right here, and the 3 was the root. Are you seeing? Do you see where to place the numbers? If it's a rational exponent, do you see where to place it in the radical? Okay, let's go to a new slide really quickly. If I had 5 to the 8/3 power, everybody with your shoulder partner, I want you to rewrite that as a radical. Everybody try it quickly. Okay, make sure everybody knows how to do this one. Brienne, make sure you guys know how. Okay, you guys, the bottom number is your index right there. The cube root of 5 to the 8th power. Got it? How many of you had that? Okay, let's go again. Let's go x to the 5/2 power. Yeah, you could simplify that, but we're not going to do that right now. We're just relearning how to rewrite them. Go ahead and do that one. So you should get the square root of x to the 5th, like that. How many of you get that? Raise your hand. What? I've explained it several times. Who wants to explain it? Okay. Go ahead, Robert. Kelvin. It says Robert on your thing, but I forget. Sorry, Kelvin. Oh, okay. Yeah. Just like if I have 1x squared, do I write 1x squared? I just write x squared, right? Same idea. If it's a square root, I could write it like this, but when it's a square root, we don't put a 2 there. Okay, good. You guys understand that? Okay, so that's what we're doing. We're using those rational exponents. So going back to this problem right here, okay, we're just timesing by the square root of 3 each time, or the cube root of 3 each time. All right, you guys, I'm not going to say any more about that. I want you to go to the go part right there on problems like 15, 16, 17. Last year, you guys, this is a review of what you learned last year. Rules of exponents. Do you remember doing rules of exponents last year? Yes. You would have done it in your secondary math 1 classes. Okay. How do you rewrite 3 squared times 3 to the 5th? Yeah, you write it as 3 to the 7th. 3 squared times 3 to the 5th means, the 3 squared means 3 times 3. That's that grouping. And the 3 to the 5th means 3 times 3 times 3 times 3 times 3. That's a total of how many 3's being multiplied together? 3 to the 7th. Well, the fast way to get that would have been 2. 3 to the 2 plus 5 is 3 to the 7th. Okay? You can add, okay, when the bases are the same and you're multiplying, you can add the exponents. Got it? Like number 16. Let's go to 16. Okay, 16, you have 5 cubed over 5 squared. Well, if you expand it out, 5 cubed means what? 5 times 5 times 5, and 5 squared means 5 times 5, right? Well, 5 divided by 5 is 1. 5 divided by 5 is 1, and what are you left with? 5 over 1, which is 5. Okay? Well, what's the fast way to do that one? 5 to the 3 minus 2, which would be 5 to the 1 power, which is just 5. Okay? So this is rules of exponents that you were supposed to learn last year. Do you remember learning them now? Kind of? Okay. Yeah, I know you probably don't remember them. I'm just trying to see if you remember. Okay? I just want to make sure you were taught them. How many of you were... Yeah, now 17... I've got to put my glasses so I can see it. 2 to the negative 5. 2 to the negative 5 power. Well, you guys, I'd have to go back to negative exponents, but do you guys remember? Yes. Yeah. Anytime you have, just remember this right now. We're going to talk about it, why it's like that. But 2 to the negative 5th power, if you have something at negative power, if it's in the numerator, put it down in the denominator and make it a positive exponent. Okay? And then 2 to the 5th power is 32, so you could write it as 1 over 32. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times the 5th 2 would be 32. Okay? Now, brings up another point. What's 17 to the 0 power? I heard someone say the right answer. It's 1. You know why, you guys? Let me show you why. How many of you know why something to the 0 power is always 1? Alex. Yeah, if we used what we learned about subtracting right here, if this holds, I would have 17 to the 1 minus 1 power, which is 17 to the 0 power. Well, we already know that 17 divided by 17 is equal to 1, right? So 17 to the 0 power has to be equal to 1. I could have done it like this. I could have went 17 to the 3rd power over 17 to the 3rd power. Well, that's 17 to the 3 minus 3, which is 17 to the 0. But I know that a number divided by itself is always 1. So any number to the 0 power is always 1. That was another rule you should have learned last year. Okay? Anything to the 0. 0 to the 0 power is undefined. Actually, yeah, because then you would have to be dividing by 0. 0 to the 0 power means that you had something like 0 to the 2nd over 0 to the 2nd, right? But we all know you can't divide by 0. It's undefined. So 0 to 0 power is undefined. Okay? All right, now, so we did 15 through 18 right there, you guys. I'm going to let you guys struggle with 19 and 20. Turn it over to the back side. Turn to the back side. Number 6 through 11. Now, find the value f of 2. What do, you guys, find the value of f of 2? Okay, put in 2 for x. Well, if we're looking at the graph, we got to find 2 on the x-axis. Well, I go over, it's just the second thing over because it goes up in ones, doesn't it? Because there's a 5 over there if you count over 1, 2, 3, 4, 5. So I go over 2. If I go up, where does it land on? 2. So what's f of 2, everybody? 2. Now, the next problem, number 7, says, find where f of x equals 4. Well, what does f of x represent? It represents the y. So find out where y is 4. Where is y 4? What x value would give you a y value of 4? 4. 4 comma 4 is on the graph, okay? So that's how you do that one. I am going to let you guys finish the rest of that one. We're going to move on to the assignment now. Okay, so this is the task for Module 3.2. So Carlos and Clarita, the Martinez twins, have a summer business every year for the past 5 years. Their first business, a neighborhood lemonade stand, earned a small profit that their father insisted they deposit in a savings account at the local bank. So they're starting a business, and they're going to put their profit in the bank, okay? When the Martinez family moved a few months later, the twins decided to leave the money in the bank, where it has been earning 5% interest annually. Huh? Well, you guys, right now, if this was just a basic savings account, 5% is a lot. Because most of you guys probably don't even get 1% in your savings account right now, okay? But there's other kinds of accounts that do earn 5%, bonds and things like that if you buy them, okay? Stocks, a lot of stocks right now for the last 2 years, they've been averaging, 15, 20%. So if you have stocks, but stocks also lose money sometimes. Whereas, let me just put it this way: the safer the investment, the less interest you earn. The more risky the investment, the higher the rate you get back in return. So you just got to keep that in mind when you're investing your money, because you can lose money too. Okay. Now, usually in the stock market, if you don't put all your eggs in one basket, that means if you don't put them all in one stock, you spread them out over a lot of stocks, called a mutual fund, then generally, over time, it's going to go up. Okay. It might have some dips where it goes down a little bit, but then over time, it's going to go up. Dips down, goes up. Dips down, goes up. So, but these people have theirs in a bank where it has been earning 5%. There's usually, if you buy a certificate of deposit, you usually get a better rate, but it's only like 2 or 3% right now. It's not 5%. But we're just going with the story, okay? 5% annually. Carlos was reminded of the money when he found the annual bank statement they had received in the mail. And says, remember how Dad said we could withdraw this money from the bank when we are 20 years old? Carlos said to Cleta. We have $382.88 in the account now. I wonder how much that will be 5 years from now. Okay? So could we figure that out? Yes. Well, 5%. Okay, well, it says annually. It says 5% annually. So look at the table they have right here, you guys. It says Carlos calculates the value of the account 1 year at a time because it does accrue annually. That means they're going to pay the interest at the end of the year, okay? Or the amount they earned at the end of the year was 5% of what they had in there, okay? He has just finished calculating the value of the account for the first 4 years. Describe how he can find the next year's balance and record that value in the table. So I want you guys to notice these numbers, okay? I want you to figure it out, and I want you guys to tell me what number goes right there. So work in your groups on that. I'm going to pause this for a second. What'd you get for your number? All right. You should have got 488.65. Good job. Good job, you guys. How many of you got that? Okay. Did you teach them how, Kurt? Yeah. Now, right here it says, Clarita thinks Carlos is silly calculating the value of the count 1 year at a time, and says that he could have written a formula for the nth year and then evaluated his formula when n equals 5. Write Clarita's formula for the nth year and use it to find the account balance at the end of the year. In other words, do you guys see what I'm saying? She thinks that he was kind of foolish for doing 1 year at a time when he could have written a formula and figured it out from the start. What do you guys think? It's good, but I want you guys to come up with an explicit formula. You guys have been doing this all year. You know how to do it. Let's go. Write an explicit formula. Look. Hey, Kurt's got it right here, okay? I don't know if you remember those problems we started off on. I mean, Roger, thank you. I was talking to Roger and Kurt. They both had it, okay? Look, this is the initial amount, right? So in any kind of formula, money formula that you're going to use, this first number is going to be what we call the initial amount. And that's how much they started off with, 382.88. Times by, remember we talked about the percent, you can't times by 0.05% because that's going to give you a lower number. You have to times by 105%, which is 1.05, because it will take the 100% you started with and add 5%. And then the x represents how many months or how many years of time's gone by. In this case, we're doing it in years, so x represents the number of years. So what are we going to put in for x? 5. So I want everybody to put this in your calculator. Type it in and put a 5 in right there and see if you get the right number we had before. Branson. 1.05, because we're taking 5%, right? But if I took 5%, if I took 5% of 382.88, if you times it, that's going to be a small number. That's just going to give you the interest that you earned, right? But we want to add the interest back to what we started with. We want to take the 100% of what we had plus the 5% interest that we added. So that's 105%. Okay? So if you write a percent as a decimal, you move it over twice, it would be 1.05. Just like right here, that's 0.05, right? So it's 1.05. Just remember this. Always add 100% to it and then change it to a decimal, okay? All right. So 1.05. All right, did we get that? Did you get the right number? What was the number again for 5? 488.65. Okay, so we came up with this formula right here. Okay, so I'm going up to the next one. Carlos was surprised that Clarita's formula gave the same account balance. Erase this. Okay, so Carlos was surprised that Clarita's formula gave the same account balance as his year-by-year strategy. Explain in a way that would convince Carlos why this is so. So we've got Carlos right here in our class. His name is Branson. Okay, can you guys write a formula? I mean, can you guys explain why the year-by-year thing worked the same way as that? Uh-oh, we're in trouble now. Okay. Are you sure? Okay. Carlos could be a banker someday. You never know. Okay. We said Carlos. Okay. I'm just kidding. All right. Hey, who would like to explain why is that the case? Okay. Christian? Kurt? Why does the formula work the same way as making the table year by year? Why does that work? Well, let me write it out this way. Okay, remember when we started before, what was that? 388 point what? 382.88? Okay, so they started off with 382.88, right? And to get the next year, to find out what they're going to make after the first year, that you times it by 1.05, right? Now, if I'm going to the 5th year like that, the short way of writing that, I mean the long way of writing that, would be to times it by 1.05. How many times? 5 times, right? So when I times 1.05 by 382.88, I would get the next number. What was the next number on that table? Okay, so we get that number. And then I times that by 1.05, and I would get the third number, right? Then times that by 1.5, then I get the fourth number. Times that by 1.05, and I get, do I have too many 5s up here, or did I just skip one? Okay, and you keep timesing by that until you get to your 5th year. And you get that same number. That's why it works the same, okay? We're going to move on right here. I can't remember how much money we earned that summer, said Carlos. I wonder if we can figure out how much money we deposited in the account 5 years ago, knowing the account balance now. Could we go backwards?
Hey, Alex had a pretty cool equation.
Could we go backwards, you guys? Okay, what's the equation? Okay, Alex is going to show us equation. That.
That's the principal, investment, rate of interest, and time.
Okay, but we're going to change that. You're saying that's the interest. That's actually the interest plus the principal, right?
Yeah.
Okay, so.
That's why I put the +1 in.
Yeah, okay. But we'd really need a different name for that. But yeah, this is the, you guys, did you know this is the formula? But this is how they usually write it. They write it like this. Because I wanted you to discover it. No, okay, wait.